Welcome. Have you ever wondered how chemists know exactly how much stuff to mix together to make, well, everything? From medicines to the phone in your hand, well, that's all down to quantitative chemistry. And today, we're going to break down everything you need to know to absolutely nail this part of your GCSE exam.
So let's kick things off with a massive question. How on earth do you count atoms when they're literally too small to see? It sounds impossible, right? But chemists came up with this really clever solution. And by the end of this explainer, you're going to get it too.
All right, here's our game plan. We're going to start with the absolute foundation of it all, the mole. Then we'll see how to use that in equations, figure out what happens when one ingredient runs out first, and even tackle calculations for solutions. Think of it as a step-by-step guide to building your confidence for exam day.
Okay, let's get right into it with the single most important idea in this entire topic, and it's called the mole.
So what is a mole? The easiest way to think about it is like a chemist's dozen. You know that a dozen means 12. Well, a mole is just a name for a specific, huge number of particles. And here's the really clever part. The mass of 1 mole of anything in grams is exactly the same as its relative formula mass. That one simple link is the key to pretty much everything else we're going to do.
Just take a second to look at that number. It's called the Avogadro constant, and it is gigantic. That's a 6 with 23 zeros after it. That's how many atoms or molecules you'll find in just 1 mole of a substance. It's the magic number that lets us connect the invisible world of atoms to the grams we can actually weigh out in a lab.
Now this formula right here is your new best friend. You're going to use it all the time. Moles equals mass divided by the relative formula mass, or MR. It's the bridge that connects everything. And a little tip for the exam, if you're not a fan of rearranging equations, just pop this into a formula triangle. It makes finding mass or MR so much easier.
Okay, theory is great, but let's see it in action with a typical exam-style question. We've got 88 grams of carbon dioxide. The question is, how many moles is that? Don't worry, it's just a straightforward use of the formula we just saw.
Let's walk through it together. First step, we always need the Mr. So for CO2, that's 1 carbon, which is 12, plus 2 oxygens, which are 16 each. So 12 plus 32 gives us 44. Easy. Now we just plug those numbers into our formula. Moles equals our mass, 88, divided by our Mr., 44, which gives us a nice clean answer, 2 moles. See? Not so bad.
Awesome. Now that we can switch between grams and moles, let's see how that helps us with actual chemical reactions. You see, a balanced equation isn't just a bunch of letters and numbers, it's more like a recipe, and it tells us exactly how many moles of each ingredient we need.
Look at the big numbers in front of the formulas here. You've got a 2 in front of the HCl, but nothing in front of the Mg. When there's no number, we just assume it's a 1. So this recipe is telling us that for every 1 mole of magnesium, we need 2 moles of hydrochloric acid. That 1:2 ratio is the secret code that unlocks all of these reacting mass calculations.
Okay, so here's how they'll test you on this. They'll give you the mass of something you start with, in this case 24 grams of magnesium, and they'll ask you to figure out the mass of something you'll make.
Just follow these 4 steps and you can't go wrong. Step 1. Find the moles of the thing you know. So 24 grams of magnesium divided by its MR of 24 is 1 mole. Step 2. Use the ratio from the equation. The equation shows a 1-to-1 ratio between Mg and MgCl2. So 1 mole of Mg makes 1 mole of MgCl2. Step 3. Find the MR of the thing you want to know about. For MgCl2, that's 95. And finally, step 4. Turn those moles back into a mass. 1 mole times 95 gives us our answer, 95 grams. It's a system, and it works every time.
Okay, now, in the real world, chemists don't always mix things in the perfect ratio. Usually, you have too much of one thing and not enough of another. The one that runs out first is called the limiting reactant because, well, it limits how much product you can make. So it's a really simple idea. The limiting reactant gets completely used up. Poof, all gone. It's the reason the reaction stops. The other reactant, the one you have leftovers of, is said to be in excess. Figuring out which is the key to predicting how much stuff you can actually make in a reaction.
Honestly, the best way to think about this is making sandwiches. Let's say you've got 10 slices of bread, but only 3 slices of cheese. How many sandwiches can you make? Just 3, right? Then you run out of cheese. In that scenario, the cheese is your limiting reactant. It doesn't matter that you have loads of bread left over. So far, we've talked about weighing out solid chemicals.
But loads of reactions happen in solutions. So how do we measure the amount of stuff in a liquid? That's where a new idea comes in, concentration. And it's a super important calculation you need to know.
At its heart, concentration is just a measure of how crowded a solution is, how much stuff or solute is dissolved in a certain amount of liquid. And for your GCSEs, we usually measure this in grams per cubic decimeter, or G/dm cubed.
And of course, there's a formula for it. Concentration equals mass divided by volume. But listen up, because here comes a classic exam trap. The volume must be in cubic decimeters, or dm cubed. A lot of the time, they'll give it to you in cubic centimeters, cm cubed, just to catch you out. Just remember to divide the cm cubed by 1,000 to convert it to dm cubed before you do anything else.
And that's it. We've covered all the core calculation skills you are going to need. Let's just do a quick recap and pull all these ideas together into your very own chemistry toolkit.
So here it is, your toolkit for success. It all starts with the mole. From there, you've got your first formula to connect moles and mass. Then you can use mole ratios from equations to figure out reacting masses. You know how to spot a limiting reactant. And finally, you have your second formula to calculate concentration. Get comfortable with these 5 tools, and you'll be ready for any calculation question they can throw at you.
So you see, you've done brilliantly. With these skills, you're not just revising for an exam. You're actually learning the fundamental language of chemistry, the principles that scientists use to design and build our entire world. So keep practicing, keep asking questions, and think about all the amazing things you now understand how to build.